Let's talk about inverse functions. Let's recap. What is an inverse function? It's a function that takes an output of f back to the input. If we want to define it informally. Okay, here it's very important that the function is one-to-one. F must be one-to-one. Okay, why do we need this? Because it must take different inputs to different outputs. If it does this, then we will be able to track it back, to bring the outputs back to the original inputs. Okay, so if you want, we can say that f is invertible if and only if f passes the horizontal, not vertical, horizontal line test. Okay, this means that a horizontal line can cut the graph of f at most once. Well, let's say only once. Sounds more natural. Okay, so that's the horizontal line test. Let's see some examples. For example, we can have y equals x to the power 3, and this one definitely passes the test. No matter where we place a horizontal line, it cuts at most at one point, only once. But for example, a simple function that doesn't pass the test is x squared, y equals x squared. You see, because here, except at 0, the rest of the points are going to cut twice. So here we know the issue. Here it's not going to pass, here it's okay. We know here that for the inverse, we have two possibilities. We have the plus square root of y or the minus square root of y. So we are left not knowing which one to pick. Okay, so it's, if you want, this function takes two different x's to the same y. So then how can you send them back? You know, you will not know where to send them. Another one that is going to pass the test is the exponential. Okay, for this one, any point you choose, any x, any horizontal, is going to cut once. Okay, so this one passes the test. Here we know that the inverse is the logarithm, right? There. And another one that doesn't pass it, well, trigonometric functions, because they are periodic, they don't pass the test. For example, we could have the, whoops, that didn't look good. We could have the sine of x, right? And the sine of x is going to cut any horizontal line infinitely many times. Okay. So this one is going to fail the test. Now, I want to mention a couple of things about how to find these inverse functions. So let's work with some examples. Let's say f of x equals x to the power 3 plus 1. Okay, so, well, we know how to do this, but let me do it carefully once. So this means x to the power 3 equals y plus 1, right? We are solving for x. That's the goal. So x equals 1 plus y to the power 1/3. And that is going to be my inverse. So I can write the inverse, and I can write it with the variable y or I can write it with the variable x. Either way is good. Okay, here both are okay. Here the important thing we should always check is that when I apply f minus 1 to f of x or f to f minus 1 x minus 1, I should get x. So let's see if that checks out. Well, here we can see that actually I messed up in the very beginning. The example was with a +1, but I started with -1. So let's just modify the example. Right now it's -1. Okay, so let's take f minus 1 of x to the power 3 minus 1, and this is going to be 1 plus x to the power 3 minus 1, and that to the power 1/3, and that gives x. So very good. And then I take f of f minus 1. So this is 1 plus x to the 1/3. So this is 1 plus x to the 1/3 to the power 3 minus 1. That's 1 plus x minus 1 gives x. We are good. So here you saw that when I was checking, I realized that I messed up the problem. I decided to keep going so that you will see that actually it's very important that we double check in the end to make sure that we didn't mess up, or if we messed up to at least know. Let me show you the graphs of the two functions. So for example, let's start there. 1 plus x to the power 3 to the power 1/3. This was the inverse. Okay, and then let's add the function itself, that was x to the power 3 minus 1. Now, when we look at the two functions, you have probably noticed that there is a symmetry there, right? There's a symmetry respect to the line y equals x. Okay, so we may be wondering if this is by chance. No, it's not by chance. So to find the graph of the inverse, always start from the graph of the original function f of x and reflect across the line y equals x.